Hello and welcome to another exciting video from Ken's Trading. Today what we're going to do is we're going to replace a air terminal box. This is also referred to as a VAV box, which stands for Variable Air Volume. Since I have a box, it's a pneumatic box, it's already up in the ceiling. The part that's bad here is the shaft has become disconnected from the damper assembly, which is right here. The one that's in the ceiling has become it's broken off right here. I'm not sure exactly where it's broken off because I haven't pulled it out yet. But I purchased a stripped down box. This is a 16-inch box that was about $210. And then what I'll do is I'll take the pneumatics off of the existing box, transfer them onto this box, so this way I can save that costs for the velocity controller and the damper actuator motor. But I just wanted to show you what the box looks like. You can see here's the end of the shaft. Here's an arrow at the end of the shaft. The arrow indicates what position this is in. So if it's this way, the arrow is going like this. If it goes like that, the arrow is 100% shut off. Over here is where the round duct is going to connect to. Here you can see a flow sensing device. Red and green are the colors. So what's happening is the red is going to be the high pressure coming in this way. The green has got holes here on the opposite side that senses the low pressure, and then so the differential among these two is dependent upon how much the damper is opened or closed. If the damper is open 100%, you'll have the most differential here if you were to put a magnehelic gauge. This goes to the velocity controller so it can determine how much flow or airflow is traveling through this box. On the other side of the box, you've got your drive clamps and your C-clamps. So these are the strips here. This here is the C-lock. It looks like the letter C. When you butt the two up, you'll put it down inside of here. And then the other one is the S. If you look at it on the side here, it looks like the letter S. And then that will go in here. Now, of course, this has to all be cut and everything, but this is what the raw materials look like in order to change it out. So that's it for now. This is a 16-inch Titus box, model number DESV. Alright, so there you go. Okay, now I am in the ceiling and you can see the fully connected existing box that's bad, that needs to be replaced. And you can see here is the velocity controller and this is the damper actuator. These are connected to this plate. What I'm going to do is, it looks like it's held in by two self-tapping sheet metal screws, that I'll pull those out and transfer this plate onto the other box. Now here you can see the end of the shaft where there's an arrow. I'll zoom in there. Now that's full opened. Oops, sorry. And then over here is full closed. Now that's supposed to stop. And you see how that just kind of spins all the way around? Something is wrong here. Somehow this shaft is no longer connected to that damper. It shouldn't be spinning like this so freely. The only way for me to figure out what's going on is to pull this box completely out of the ceiling. So I'm going to have to disconnect the C-lock and the S clamps. Plus I'm going to have to disconnect where the round duct connects onto the VAV box. So I've already disconnected the pneumatic portions here. I just cut the high and low off of the flow sensing device and took the T out. I'll have to take out this one last line here. This is the main line going to the velocity controller, the main air pressure line. I'll cap that off and put that aside, and then I'll start dismantling this box. Okay, here we are. I wanted to give you an update on where I'm at with this VAV box. I've removed the pneumatics that was around here. You can see the shaft here is just flopping all over the place, so obviously it's broken somewhere on the inside. We'll figure that out once I get it out. I've taken out the two C drive locks, which are, let's see here, right here is one side, plus I did the other side, and I put in a couple of support brackets that they didn't have. One of them is this one right here. I put that one in, anchored it into the ceiling, and then so I could support the box, because once I pull this out, I want to make sure everything is supported. I also put an extra support here for a temporary basis to hold the box while I'm pulling it out. Now I've broken this seal that was here from the round duct into the box, and now I'm working on this one back here. I'm going to pull this section of the duct out, so I'm loosening up this one here so I can pull this top section out. So that's the next step that we're on. Once this section comes out, then the box should be able to just pull forward towards me, and everything should be supported pretty good when that happens. So that's it for now. Okay, the box has come out, and this is the stage where I'm at right now. So you're looking at the coil with the box removed. This here was the strap that I had put in temporarily just to support the box while I was removing it, just so I could have something there. This strap, it's a good thing I installed this strap here, because that was absolutely needed. Otherwise, all the weight would have been suspended just on this copper and the coils and everything, and it would have been crazy. So it was a good thing I installed that. This is what the open duct looks like. The air is on right now, so there's good airflow coming out. So because we're doing this during normal business hours, not after hours. We got like an inch, just over an inch of static on the main duct, so there's some pretty good pressure here. And then there's the duct up top that we took and removed out of here. So we removed that section, then we came and broke this box and took it out from here. Now I'm going to go show you the box. Alright, here are the two boxes side by side, the new box and the old box right here. And I just wanted to verify that they were going to be an exact fit replacement, and they are matching up perfectly, the height, width, and length. Now here, the shaft, you can see that flopping all over the place, and I was wondering what was going on there. So on the inside, what I have found is that the shaft has physically sheared off where it connects onto here. So there's just, that's an unrepairable situation. So it's good that I got the replacement box there. But this is the what happened and why this going through all this work in order to replace the box. It's because this one became inoperable. It sheared off. When I go to put the pneumatics in, I will make sure that I don't put undue stress on the new box, because I certainly don't want the same thing to happen. It's possible that the technician allowed this, when this damper came to a stop, he may have had too much pressure on that, and that's why it sheared over time. I'm going to make sure that that I don't have that pressure when I do my calibration. And I'll show you that step when I get to it. And that's it for now. Alright, we got the new box in place. We have on the drive lock clamps, the C clamps, the S clamps, so that's all put in place. We still have to put on the pneumatics that are going to go on right here. this here will probably be in the way, so I'll probably have to end up moving this. So I'll put some more tension on the other one because it slackened up right there. Right now this is just bolted in with the self-tapping sheet metal screws where the duct connected there and right here on this seam, and come back later and seal that up. So that's the progress that we've made so far. We're back together, just got to put the pneumatics in. Alright, so far the pneumatics has been anchored to the box with 4 self-tapping sheet metal screws. The linkage from the shaft to the damper motor has been attached, normally opened, so the shaft is open now. When the motor has, this is a 5 to 10 psi spring range, when that protrudes out, then that will close this damper. We also tightened up on this strapping to put some more suspension here, and I was able to leave this second strap in place, and I just kind of moved it so that it wasn't going to affect this damper at all. So all that's good. And we're making sure that our tubing is completely away from the linkage right now. Okay, so now I'm working on the high and low going to the flow sensor at the beginning of this VAV box. And it looks like I'm going to have to trim this tubing out a little bit. So let me just quickly do that. These taps are, if you had a magnehelic gauge, you could attach them to these T's going to the high and low. We didn't bring our magnehelic gauge with us to this job. I don't think we're going to need it. If we need it, we'll go get it, but I suspect we're going to be able to do just fine without it. The thermostat that we're going to be attaching to is a reverse acting thermostat. And this particular velocity controller is a it's a CSC-3011, which generally is for a direct acting thermostat. But I believe the technician who installed the first box changed the reset start point to 8 psi. So I'm just going to verify that when we go to do our work. Okay, right now what we want to do is we want to confirm the reset start point on this velocity controller. This is a CSC-3011, which is meant for direct acting thermostats, and we have a reverse acting thermostat. The reset start point should be 3 psi-G. This one came factory set at 8, and I want to make sure that the technician changed it. And the way that I'm going to do that is I'm going to connect my squeeze bulb here to the T port, and I'm going to start squeezing, and I'm going to notice at what pressure the G port begins to increase pressure. So here I go, and right there it came off, and it's at 3. So this is changed. So this is now a CSC-3021. So that is good for reverse acting thermostats. Alright, so I'm going to pull this, I'm going to pull out the G port now because I verified that. Now we're going to do the high and low. So I'm going to take the inline pressure gauge out of there. I'm going to put in the cap that belongs on the G port. I'm just going to cap that off because that has to be capped under normal conditions. Okay, there it is. That's capped. Okay, now that we've confirmed that this is calibrated to a CSC-3021, which is for a direct acting thermostat, now we're going to adjust the low and high pressures for the airflow. Now because it's a CSC-3021 and there's no pressure currently on the T-port because I got no pressure on my squeeze bulb, I'm going to adjust for maximum airflow with the minimum knob, or the low knob is what I should say. So I'm going to take the low knob, and I want to increase that because this damper is too closed. So there's a little arrow here, and I'm going to turn that in the direction of the arrow, and you're going to see the shaft pull back in, and you're going to see this open up more. So what I want to do is I want to, if this customer is too warm, I want to give them plenty of airflow. If the space was too cold, the thermostat would sense it and cut them back naturally anyways. So it's perfectly fine for me to increase the airflow at this time and give them maximum airflow if they need it. So I'm going to increase that some more. And this happens slow. It's not a fast action here, but this is turning. This shaft is retracting because it's under spring tension, and I can see the shaft is opening, so the butterfly is opening inside. And I'm going to go more. Okay. Alright, that's doing good. I'm going to keep going. Get plenty of airflow in here if they need it. And it just takes time to go through it. Give a little bit more. Okay, that is just about open to 100%. It's not quite 100%. Give it a tad more. We'll let it go to 100%. A little bit more. Just going to get that to 100%. Okay. Now I'm going to say that the maximum airflow is calibrated correctly. Reverse acting thermostat, and it's at 0 psi on the T-port on the velocity controller. Now I'm going to take my T-port and I'm going to put it above 10 psi. I'm going to put it over to 15. Now with 15 psi on here, this is going to be adjusting the minimum or the low set point. You know what? I've actually got a leak in here, and I got to keep pushing the squeeze bulb. So what I'm going to do, so I don't have to keep doing that, is I'm going to connect on the T-port, and I'm going to take the thermostat and put it to full heat. So I'm going to take a moment to do that. Okay, now I've got the T-port connected from the thermostat because my squeeze bulb had a small leak. I didn't feel like fixing it and troubleshooting it. It's just easier to do it this way. So I've got the thermostat set to 80 psi.
80 degrees?
I mean 80 degrees Fahrenheit. Yeah. And with 80 degrees Fahrenheit, it's giving a pressure signal here that's at least 15 pounds. So it's got very high air pressure on the T-port right now because it's a a reverse acting thermostat. Now, what's happening is the velocity controller is saying, okay, I need you to go to a minimum position. Now this minimum position It's cut back from full airflow, which is where it was at, but that still looks like a pretty aggressive minimum. Now if I wanted to be 100% professional, I should put my flow hood on the supply grill diffuser coming into the office, determine how much CFM the office would need, or look at the blueprints to 100% calibrate what the proper amount of opening is here for the minimum. But I don't have a flow hood at this job, so I'm going to go by feel. So what I can do is I can crawl down off my ladder, just put my hand up to the diffuser, and I can just kind of feel how much airflow, when the damper is looking like that, how much airflow it is, and I can adjust that minimum according to this. This isn't the winter, we're during summertime right now. Another thing I could do, if we were in the winter and I had my boiler running, what I could do is I could run the boiler, run hot water through the coil right here, and then see what the temperature is coming out of the space. Well, if the customer is too cold and it's 68 degrees, well, I know that I want that air temperature to be, you know, 90, 100, 110 degrees Fahrenheit if I can get it, and I can adjust this minimum in order to get a good balance between airflow and temperature to get that customer into a nice warm space between 70 and 75 degrees. So what I'm going to do is I'm going to crawl down off my ladder. I'm just going to feel how much airflow is coming out with that, and I'll be right back. Okay, we have determined that the airflow is too high and it needs to be cut back. So we still have high pressure here. I'm going to take the high knob. Hang on one second, I just want to see. Okay, it's this knob right here, and I want to decrease the airflow. So what I'm going to do is move opposite the arrow, because I want to decrease that airflow. That should be this direction. I want to verify that the stem is that the shaft is extending, and it is. So I'm going in the correct direction, and I want to cut that back, not off, but just slightly off. Not a 90-degree angle, but maybe an 80-degree angle. Okay. So we are extending. I'm going to let that settle out, and I'm going to go back down, and that shaft looks pretty closed off. I'm now going to feel that airflow to see what we checked airflow, and airflow is still too high. A lot better, but just slightly too high. So I'm going to take and I'm going to cut it back a little more. There's a notch here so I can get an idea of how much I'm moving. I'm just going to move this about 1/8 of a turn. This should be extending. Okay, I don't want to shut it off, but I just want like a trickle of airflow. Well, that looks like it may have extended. It looks like it's still okay. Now what I'm going to do to make sure that I still have a trickle is I'm just going to take this. Now hold on a minute. It looks like it's off. It looks like the thermostat's closing off and it's putting 100% pressure on there. I'm just going to take it and shut it off by hand. I'm going to see if this pulls back. Because the flow sensing device right here is telling the velocity controller that, okay, we've shut off 100%. And if this knob is set correctly, then this should come back to prevent it being 100% off. Because I don't want it to be 100% off. Okay, it is coming back. I can see it coming back because there's notches here. Just a black Sharpie notch here. It is coming back. I want to make sure that we have some airflow, which we should have. I just want a trickle of airflow in here. The movement is very slow, but it is moving. Okay, it's still moving slowly. I'm going to give it a little more. Alright, I think I need to increase that a little. It's slightly off. That might be okay. I'll check that before I make any more changes. Okay, we went back one last time and we checked airflow. Airflow is at a trickle, which at this point in time is which is an airflow that I want. I can always come back up here and adjust it if I need to, but we're in summertime mode right now. This customer is usually cold, so this is a good setting. So I'm going to leave that setting alone. So when you've got high pressure here, it goes to the minimum. If you pull out the T-port, giving it on a reverse acting thermostat, telling the unit that you want cooling, you're going to see this thing come back and you're going to see the shaft open up, which is exactly what it is doing right now. Let me zoom in on that so you can see that. You can see that is opening up and the motor, damper motor, is retracting due to the spring tension, allowing more airflow. That's just because I pulled out the T-port out of the velocity controller. So this is operating exactly as it should now. I do need to come back to this job site and do when the air pressure is off, so I can put sealant, duct sealant on the joint here. I'm going to put some metal tape on the joints that I opened up, which is this joint here, and I removed a little bit of tape here because I was going to see if I was going to break a different seam apart, so I'll put some tape on there. Plus I need to go and put the insulation back around this duct right here, but I can't do the insulation until this gets sealed. These are just metal tape seals, so that's fine. And then of course I also need to use the duct sealant compound to go around all of my C drive clamps and the S clamps underneath and on top. So I have to go around this whole box over the weekend. So that's it for now. Alright, here you can see the ductwork is got covered with insulation. Before I put the insulation on, I put some metal tape around the seams that had potentially could leak air, and then wrap that with baling wire, keep that insulation on. Thermostat is set to 73 degrees and locked down, and everything else is buttoned up here. I just got to open up the valves there and then come back over the weekend to put the duct sealant on all the exposed seams here and then around the C clamps and S drive clamps. So that's just and then we also tightened up on the support brackets that were holding the box and the plenum after the coil. So all that is cinched up tight, and that's it for now. Alright, I'm getting towards the tail end of this project. Came in here after hours and I'm getting ready to put on DP1010 as the duct sealant with this paintbrush right here. Consistency is kind of like peanut butter, and I'm just going to apply that all the way around. And let me show you before I put it on. I'll show you the before and after. Alright, here's the VAV box. This is after hours, so there's no static pressure inside the duct. This seam right here is one of the seams that I'm going to be hitting, and then the second seam I'm going to hit is right here. That's old duct sealant. I have to do a new seal there because that's where I had to break it apart. And I'm going to do that all the way around, and then I'm pretty much done. There's the insulation back on the duct. Everything is sealed there, and the pneumatics and everything is all hooked up. So that's ready to rock and roll. I just need to seal this up. Okay, that's it for now. Alright, here's the box sealed up from the opposite end. You can see here I did that seal all the way around. I also went and sealed any little thing that on the box that could have potentially been opened, including screw holes like this right here. Here's the C drive clamp and the S clamp. That was all sealed up there, all the way around on the side. It's this one right here. That's the one I just installed. That's all been sealed, and on the top too. So that's all been sealed all the way around. Okay, and here's the first side. There's the joint that I sealed right there, all the way around, right there, as well as everything on the box. This joint here, this one going this way, as well as this one going up right there, and also over here on this side where the pneumatics is, the C drive clamp as well as the S clamp top and bottom. So that's pretty much the job completed. I just got a little bit more to do. I just wanted to, I got a sticker, I got the CFM stickers. I printed it up with my camera. I took a picture of the picture of the CFM and had it laminated. I'll put those on the box, so in case if I ever want to hook up a Magnehelic gauge, I'll know what those are. But pretty much that's it. You know, pretty good job, well done here. All right, thank you. Okay, here's the final deal. Everything's wrapped up. I had taken pictures and put a couple of laminations on for the model information about the box, the Titus box, as well as the CFM chart, because the pneumatics were blocking that when I put them on. So rather than have them blocked, I took a picture of it and then printed it, laminated it, and now just taped it right to the box, so this way you have access to all that information. But the duct sealant is now on, everything's all sealed up, and this box is ready to be put back into service. Okay, what we've done is we finished up at the VAV box, and now we're going to check the sensitivity adjustment on this thermostat. First thing you do is put in your pressure gauge in the tap portion, and now in order to check what the current sensitivity adjustment is, we're going to change the set point on the thermostat to read 3 psi G on the pressure gauge. Then we'll make a note as to what that temperature is. So we're going down to 3, and the temperature on the set point is what?
68.
68. Now change the pneumatic output pressure to 13, you know, and that's working with a variable of 10.
$73.
73. So that's exactly 2 psi per degree Fahrenheit. What we want is, because this particular hot water valve has a spring range of 10 to 15, it's higher than what we would like to see installed. We were not the installers of this valve, but because that valve is set from 10 to 15 psi spring range, we would like to change the sensitivity adjustment to 3 psi per degree Fahrenheit. That will give this customer a little bit better temperature control. The way you do that is you take the slide bar, and hang on one second here, I'm trying to show that. I didn't bring my,
Use this point.
that's okay. Okay, this is the slide bar right there. We're going to take that slide bar, we're going to push it down slightly, and then we're going to continue to see if we can't get 3 psi per degree Fahrenheit. That'll be a little bit better range for this customer. So go ahead and move that slide bar down. Okay, you got to kind of move it down on the left side and the right side, and it's going to move it about 1/8 of an inch down. Are you there? Good to go?
Yeah. Sure.
Okay, now go ahead and put 13 psi on your pressure gauge and see what that is.
That's 73.
73. So now go ahead and change it to 3 psi.
Didn't move at all.
Didn't move at all. So go ahead and move that slide bar down some more. And since he's closer to 13, you might as well start at 13.
Is about 70.
70. Now he's at 70. Now he's going to drop that to 3 psi, and we're going to see what that temperature is.
67.
67. So now, if you take and do the math on that, hang on one second. Okay, we finally got the thermostat to be at a sensitivity of just over 3.3. So what we did was we got the higher temperature, the higher number, pneumatic number at 69 psi, and then we, 69 degrees Fahrenheit, and then the other lower was 66, which equaled 3 psi, 3 degrees Fahrenheit for 10 psi. So then you take 10, you divide that by 3, and that equals 3.3 is the sensitivity adjustment. Factory setting is 2.5, so we've increased that, and I'll go through downstairs why that is important with this particular spring range. And then once we got done doing an adjustment on the sensitivity adjustment, then we went through, and that's again by moving this slide bar right there. By lowering that slide bar, we increased the sensitivity adjustment. Then after that, then we went and calibrated the thermostat at room temperature. We calibrated it to be at 5.5 psi at set point, and then we took care of that. And now we set the thermostat at 73 degrees, which is right there, and now we're going to go ahead and put the cover on right now, and then this is going to be, we're going to wrap up at this end. Okay, so now I'm back here at the classroom situation where I can explain a little bit more in greater detail why that sensitivity was important to me on the thermostat. Now, on the zone that we were just working on, the zone that we just replaced the VAV box, the hot water, the existing hot water valve had a spring range of 10 to 15 normally closed valve. Spring range was 10 to 15 psi. This is higher spring range than what we would normally install. We install spring ranges of 5 to 10. So this is way higher than what we would normally install. I could even do a spring range of 8 to 13, but this spring range is a little on the high side, and now I'm going to explain why. Now, the sensitivity adjustment on the thermostat, the factory setting, is at 2.5 psi per degree Fahrenheit. So I'm just going to write down psi here. So this is the factory setting. We changed our thermostat to about 3 psi per degree Fahrenheit. So this is what we changed it to by moving the slide bar down. Before we started this job, our thermostat wasn't even at the factory setting. It was at 2 psi per degree Fahrenheit. I know this because we checked it. Okay, so if we had not touched it and left the hot water valve alone, and left the thermostat sensitivity adjustment alone, this is what the customer would have experienced. Now at 72 5.5 degrees Fahrenheit, if this was the actual room temperature and you calibrated the thermostat to 5.5 psi, in the wintertime, as the room begins to get colder, this is what the temperature would be. Now this is just a half a degree increment from here to here, and then I go full degree increments all the way down. So what would happen is the branch pressure, this is 72.5, these are in degrees Fahrenheit, and this here is the branch pressure, B-R-A-N-C-H. This is what's going out to the VAV box. Now, you would have went, as the room got a half a degree colder, the signal would have changed from 5.5 to 6.5. As it went from 72 to 71, you would have had a branch pressure of 8.5. Mind you, your hot water valve is not even opened yet. As you went from 72 to 71 to 70 rather, you would have had a branch pressure of 10.5. Your hot water valve would just be cracked open at just a little bit, just above 70 degrees Fahrenheit. Well, what temperature do I want my customer to be at? I want my customer to be 70 to 75 degrees Fahrenheit. 72.5 is the exact midpoint of this, and that is why that is my starting point here. Okay, I want my customer to be between 70 and 75. If I'd have left that alone, am I going to be able to do this in the winter time with that spring range on that hot water valve? No way. Now, if I had changed it to the factory setting, this is what the customer would have been experiencing. At 72.5, you're calibrated to the same 5.5. As the room temperature dropped by a half a degree, it would have went from 5.5 to 6.75. From 72 down to 71, you would have had 9.25. Still no hot water valve, but when you jump down to 70, you'd be opened at 11.75 psi on this here. So you'd be opened a little bit by the time it got to 70. But probably this temperature, the customer would be between 69 and 70, bouncing around there. But we increased it to this point. We went and changed our sensitivity to 3 psi per degree Fahrenheit. Now this is what our customer is going to experience with this hot water valve. What I did was I calibrated the room at 5.5 at 72.5 room temperature. As the room gets colder, you come down here to 71, and now you're at 10. When you're at 70, this valve is opened at 13 psi. So it's a little bit better than halfway opened at 70 degrees Fahrenheit. And if the room still continues to drop, that valve is going to open 100%. I've got a much better chance with this valve of keeping this customer pretty close to that. Now that 70 may drop down to 69, but for sure I'm going to be able to keep this customer between 69 and 75 degrees Fahrenheit throughout the year. On a worst case scenario, this customer is going to be too cold in the wintertime. We will go ahead and we will replace this valve for a valve with the proper spring range. Somebody installed one, but I'm trying to leave the hot water valve alone. I'm just trying to change my sensitivity on the thermostat to try to get maximum life out of that valve before I take it any further. And I did this whole thing because we had done a major change to this zone. We changed out the VAV box. Because we changed that out, it's going to force me to look at, okay, is there a hot water valve? Is there a coil? What's the spring range of that valve? Is it normally open, normally closed? Did the tech install the right components? Okay, they did, but the spring range is a little high. Okay, what about my thermostat? Can I make some changes there? Is it the right thermostat? Our thermostat is a reverse acting thermostat, and we just changed the sensitivity, and we should be okay with these settings. So at this point in time, we're going to consider this job 100% complete, and we are going to wait and see how this customer, some customers can withstand a little bit colder temperatures in the winter compared to other temperatures. Some other customers, I should say. But I think our customer is going to be okay with what we have provided. And that will conclude all the segments related with the VAV installation replacement, and thank you.